Hi everyone, welcome to our video on using implicit differentiation to find an equation with respect to another variable when we're doing the derivative. So often we use implicit differentiation when we have rates, and rates are usually based on time, so like miles per hour or dollars per month. Okay, so time is often one of the main variables, and so the only thing that we need to do is right here in the bullet, we only need to attach d whatever variable dt after we do the derivative of any variable that is not t. So for instance, find the derivative with respect to time, and so time we assume we're using t. Again, notice I don't have any t's in this equation, so we'll still just do the power rule. So 2 will times 5 to give us 10, and then we have x, but we're doing it with respect to time, so we have a different scenario. So if it was just with respect to x, we wouldn't really write anything, we would just say 10x. Okay, but with respect to time, we will now attach dx dt, like that. And then equal to the derivative of a constant is 0. And that's it. Often we typically just leave these as is, and we don't solve for anything. We just do that. All right, that's it. That's all it is to it. Okay, and then let's look at number 2 here. So on number 2, again, notice we have a product, so you have to be careful of that. There's a product right there. And remember our product rule just to the side. So using these letters is u prime v plus uv prime. All right, and so with my product rule, we'll plug in as we go, but, and I forgot, I usually do it in blue, so we did the derivative, so that was the derivative with respect to time. Let's show our derivative with respect to time here. Okay, so doing the derivative, I have the derivative of 3x would be just 3, but again, we're doing it with respect to time, so it's a special case, so that means we attach dx dt to it. And then we have minus, and then let's set up our big parentheses. There we go, lots of space. Now using, so there's my u and v, so u, v. So the derivative of u, the derivative of x would be 1, but attach dx dt to it. And then my v is just y. And then we have plus, my u is just x. And then my derivative of the v, which is the derivative of y, would be 1, but again, attach dy dt. Okay, so it's whatever the letter is, dt. Okay, so notice I have dx dt and I have dy dt. And then equals, okay, so we finished our product rule, equals the derivative of 10y, which the power rule tells us would be 10, but with respect to t means dy dt. Okay, and then that's about it. We'll just simplify somewhat. Let's go ahead and distribute. So I have 3 dx dt. Distributing the negative would give us minus. Now the 1 I don't really need. We would probably put the y first though. So minus y dx dt. And then minus, okay, so this negative distributed. So minus again. X times 1 we would just say is x. And then dy dt equals 10 dy dt. And then typically that's it. We usually don't try to solve for anything after that. Okay, well, or we use them in a different case, and we'll see that real soon, but that's it for now. Okay, so that's how we do these with respect to time. All right, it doesn't have to always be with respect to time, though. Let's do one other type of problem where they give us the demand equation for a product is 5p squared plus 8q equals 1,000, where p is the price per unit in dollars and q is the number of units demanded. All right, so on this it says find and interpret dq dp. So this means we're doing the derivative with respect to p. With respect to p, which means the derivative of p terms we don't attach anything to. Derivative of non-p terms we attach this to. Okay, so derivative of non-p terms get d whatever. Let's do parentheses d parentheses dp. Okay, and so our equation, let's go ahead and write it, 5p squared plus 8q equals 1,000. Okay, so doing our derivative. Okay, so now we're doing our derivative. The derivative of 5p squared would be 10p. And then I did it with respect to p, so I don't need to show this because that would be dp dp, and that would just reduce to be 1. So now I can continue to move on. So plus 8q's derivative would be 8. And then the derivative of q, though, with respect to p is dq dp. And then equal to 0, because the derivative of 1,000 is 0. Okay, and so at this point, maybe we can go ahead and solve dq dp here. I'm going to do it in one big step. So dq dp is equal to, so we'd subtract the 10p over, and then we would divide by 8. It would eventually give us negative 5 force p. Okay, so I'm skipping some steps because I wanted to get to this. Okay, and so interpret this. So this is the change in Q with respect to P. So this is the change in the quantity with the respect in price. Okay, so that's all it is. So this is the change in quantity with respect to price. Okay, so that's what that one means. And then let's do this second one. So find and interpret the dp dq. Okay, so similar so this means with respect to this q letter. So derivative of non-q terms gets d blank dq. Okay, so anyway, so we'll just rewrite our equation. Okay, and we'll go through it and do our derivative of each term. Okay, so let's just cite. I don't want to write this whole thing out because I'm going to just paraphrase it. We need d blank dq when it's a non-q term. So for instance, immediately we would have 10p. So we did the derivative, but it's with respect to q. So this would be meaning attach dp dq. And then now keep going, plus this derivative would be just 8. And it is q already, so I wouldn't write dq dq because those would just cancel. So it's just 8. And then equal to 0. Okay, and then now I want to solve for dp dq, and we could do that. Let's do it in one big step again. Okay, so if I were to solve for dp dq, we'll say it in words. We would subtract the 8 over, and then we would divide by 10 p. Okay, so we would get, actually, yeah, so minus the 8 on over. No, maybe I should show that. Okay, so maybe doing it in words can backfire. So I have 10p dp dq equals negative 8, and then dividing by 10p, let's go ahead and reduce that. So I'd have negative 4 over 5p. Like that. Okay, so we solved it, and we have this p left over. Notice the p's in the denominator on this one. The p was not in the other one. Okay, so be careful with how it is solved. Okay, but all this means to interpret, this is the change in price with respect. Change in price with respect to quantity. There we go. So that's all it means to interpret it. All right, so if you have any questions, please let me know. Otherwise, thanks for watching, and I will see you again next time.